This is Dr. Sirisha, working as Associate Professor in Institute of Aeronautical Engineering College. Today we are going to look at one of the most prominent sorting techniques, which is a selection sort. I'm going to show you what a sorting technique basically is, what are the different types of sorting techniques we have, what is a selection sort, what is the basic algorithm of it, a small animation on the same, how the elements are swapped in case of selection sort. Then with the help of Python, I'm going to show the coding of selection sort. Let's begin our journey. What is sorting? Sorting is nothing but arranging the data in either ascending or descending order. There are many sorting techniques prominently known when we are in academics. That is starting with bubble, selection, insertion, quick, merge, heap, shell, and load more, right? So in this video, I'm going to cover selection sort, one of the most prominent one, right? Coming to the selection sort. In this, the elements are, in bubble sort, we compare the consecutive elements repeatedly so that by the end of each iteration, the largest element in the list is going to come its right position, right? Coming to selection sort, it repeatedly finds the least value if you are going for ascending order and brings it to the first position. So if you are considering ascending order, with every iteration, it is going to bring its least value and bring it to the least index position, right? So coming to the best, average, and worst cases. So the drawback with this is its complexity. It is very high in time because it uses nested loops. In the language of programming, if I talk, it uses nested loops, which raises its complexity. Okay, so coming to memory wise, it is very wise to use because it does not use any extra space to store the data, and it is a stable and in place one. Data will not be picked from the list or placed somewhere else, nothing like that. Okay, so data will be there in the list itself. It is a completely in place one. Let's have a look at the algorithm. So starting with the first element, we search for the smallest element in the array and we bring it to its first position, right? So repeat the same. So when we move from the second position for the second smallest element, bring it to the first index. And guys, have a look. If you have n elements in your list, n number of elements in your list, then how many times you have to run? N minus 1 times. Because in the nth time, the element will be only 1 and it will be at its highest position. There is nothing to compare over there. So n minus iterations it is going to take. Okay, this is a simple selection sort algorithm. Let's have a look at its example with a small animation. Let's have a look at this list, which is very small, which have 5 elements, right? So how selection sort is going to work, how it is going to select the elements, right? Let's have a look. So I'm going to take 3 pointers, I, J, and M. I will be pointing to 0th index with its first iteration, with the first initialization. I will be at 0. Even M will be with I. That is, even M is also 0. And that means if I probably write I and M are initialized at index value 0. And J is positioned at a place just ahead of I. That is, J is equal to I plus 1, right? So, first of all, what is the condition which I am going to use to do this swapping job? The first and foremost thing is compare the elements that are pointed by M and J. If the element pointed by M is greater than j, then move the pointer m to j position. Right? That is what we are going to do. Coming to here, for example, here in this example, the element pointed by m is 21, whereas j is 54. So let's compare. Is 21 greater than 54? The condition fails. If the condition fails, just don't shift the position of either I or m, just shift j. Right? I have incremented j. When I increment j, the scenario turns like this. Now j is pointing to index value 2. Repeat the same process. Compare the elements pointed by m and j. Have a look in this one. The element pointed by m is 21 and the element pointed by j is 36. Is 21 greater than 36? Condition fails. So simply increment the value of j. So once I shift the position of j to the next element, this is the scenario. J is pointing to 18 now. Again, compare the content present at index value pointed by m and j respectively. Here, have a look. The element at m is 21 and at j is 18. Is 21 greater than 18? The condition satisfied, my dears. As the condition got satisfied, take your m and locate it at j. Right? So now m will be pointing to the same index value which j points to, and as usual, normally j gets incremented with its each step incremented. Now j will be pointing to 29. So j will be pointing to 29. Right? This will be the next scenario. Have a look. Right? Again, do the comparisons. You have to do these comparisons unless j crosses its boundary. Once j crosses its boundary, that is the end of first iteration or that particular iteration. If j crosses its boundary, it is its first iteration. Okay? Right. So compare the elements pointed by m and j respectively. Here the element pointed by m is 18 and the element pointed by j is 29. Is 18 greater than 29? Condition fails. And now increment j. If I increment j, it will go out of limits, right? So our boundary says that j can have a maximum index value of 4, right? Which is broken now, right? So it is the end of the first iteration. By the end of the first iteration, the elements that are going to get swapped is the element pointed by I and M. Swap them. Right? Initially, I was pointing to 21 and M was pointing to 18 and I swapped them. Right? Now, I is pointing to 18 and M is pointing to 21. Right? So, by the end of each iteration, I'm going to increment I value. Right? So, now this is the current position, guys. So, you can see that I have freezed 18 because 18 is the smallest element and it has come to its right position by the end of this iteration, the first iteration. So I'm going to just think of the remaining list only. That is, if the size of the list is n, it will get reduced to n minus 1 for the second iteration. Right? Again, the same initializations. I, as the value of I gets incremented, which was initially 0, now I is 1. to whatever point I is pointing to, even M is going to start its journey from there, and J will start with the very next position of I, that is I plus 1th position. So this is the basic setting of my second iteration. I do the same process of comparison repeatedly. Compare the element pointed by M and J, right? So what is the element pointed by M? It is 54, and the element pointed by J is 36. And my condition is greater than condition. Is 54 greater than 36? Yes, it is, right? Condition satisfied. So now very simple. Now change the position of M. Now M is going to point to the position which J was pointing to, and with every step I'm going to increment J. This will be the new scenario, right? So I have incremented J also. Yeah, this is the current one. Again compare the elements pointed by M and J. Here the element pointed by M is 36, whereas J is 21. Is 36 greater than 21? Again the condition satisfied. So now M will no longer point to 36, it will point to the element pointed by M, right? And J will be incremented with every step. So these are the steps, and this is the final scenario I'm going to get. Now M is pointing to 21 and J is pointing to 29. So again start the comparison. So here I have to compare between is 21 greater than 29. The condition fails. If the condition fails, I'm not going to touch the position of M. I'm going to just simply increment the value of J. But as J goes out of limits, if I increment it, it tells me that it is the end of the second iteration, right? So by the end of each iteration, what we have to do? We have to swap the elements pointed by I and M. That is swap 21 and 54. This is what you are going to get. I have swapped. So at now I is pointing to 21 and M is pointing to 54. So this will be the starting step or the initial list for my third iteration. Have a look. So this is the third iteration where I am going to consider only these leftover elements, as it is iteration 3, which means that with the first two iterations, least and the next least element are at the right position. So I am going to consider n minus 2 number of elements, right? So let me give positions to I, M and J. So I is incremented to 2, right? So wherever I is pointing to, even M is going to point to the same location, and J will be one step ahead of I. So with this will be the initialization, right? Let's start our comparison process. Let's compare the elements pointed by M and J respectively. So the elements pointed by M are 36 and pointed by J as 54. So is 36 greater than 54? The condition fails. So do not touch M, just simply increment J. I incremented J. Now J will be pointing to 29. Right? So again, compare between the element pointed by M and J. That is 36 greater than 29? Yes, it is. Condition satisfied. So once the condition gets satisfied, M will be pointing to the location which J is doing, and J will be incremented, right? So the first step will be taken, that is M is pointing to 29, but if you increment J, it will go out of limits. When J goes out of limits, we'll understand that it is the end of the current iteration. So with the end of the current iteration, what we are supposed to do? We have to swap the elements pointed by I and M. So swap 29 and 36. This will be the result. Now I is pointing to the element 29 and M is pointing to the element 36. By the end of third iteration, you can see that first three small elements are sorted, right? And this will be the first step or the initial input for my fourth iteration. This is the input for my fourth iteration where the first three elements are frozen, right? So let me start my iteration with initializing the values of I and J. Now I is incremented to incremented and it will be at position 3. M will be locating to the same place where I is locating, and J will be one step ahead of I, right? So this is the scenario. I is pointing to index value 3. Even M is pointing to index value 3. J is pointing to index value 4. Let's compare between the elements pointed by M and J. M is pointing to 54 and 36. Is 54 greater than 36? Yes, the condition satisfied. If the condition satisfies, what I'm supposed to do? M will be pointing to the index value which J is pointing, and J will be incremented. The first step, which is M position is going to change, that will happen. But if J is incremented, it will go out of list. Have a look, right? So this is the case where M is pointing to 54 and J got incremented and it will go out of limits. Once it goes out of limits, it is going to say that this is the end of fourth iteration, right? So after the end of the fourth iteration, what we have to do? Swap the elements pointed by I and M. So that's what I have done. I have swapped. Now I is pointing to 36 and M is pointing to 50, right? So now increment the value of I. Once I increment the value of I, it will be pointing to the highest index value. So what does that mean? It means that, say for example, what will happen now? If I is incremented, I will be pointing to 4. Very good. Even M will be pointing to 4, which is I's value. J must be incremented, right? So as I value is 4 plus 1, which is 5, J must point to 5, which goes out of index, right? So this itself says that I is going to run from 0 to n minus 2, whereas J is going to run from 1 to n minus 1. These are the limits. So in the current scenario, if I increment the value of I, it will reach n minus 1, right? Which means it is gone to out of boundary. So with this, I can say that sorting is done, right? It is the end of the logic and the final sorted list is in our hands. 18, 21, 29, 36 and 54. So with a quick review, guys. So selection sort is a sorting technique which is going to go for n minus 1 iterations if n is the number of elements in our list, right? Then it selects the least element in the current list, can be list or sub list, and place it in its the least index value. It is least index value. This is nothing but the gist of selection sort. In this, till now we have seen the basic algorithm of selection sort and an example with the help of animation. Let's write a Python script for the same. Hello guys, let's continue our Python script of selection sort. Let's write the driver code. I'm at a Python environment right now. I've opened a new script. Here I'm going to write the code for selection sort with the help of a small function, right? So let me write the comment for the same to show that what I'm writing for. Guys, it is very important to tell people what your program is meant for. So just a few words will tell the same, right? So implementation of selection sort. I would like to start with the driver code where I'm going to read the size, basically what is the list I need to sort and all. Then I'll throw that list to the function to sort, right? A simple driver code here, n is equal to int of input, enter the number of elements, right? Enter the number of elements, the maximum number of elements I'm going to take. And AARR is the name which I'm going to give to my list, right? So I'm going to read n number of elements into it. So list is already existing one, and with the help of map, I'm going to do that, guys. Input split, so that it is going to, I've used split function so that whenever I give elements with the space, it is going to consider that, right? So map function needs two parameters. One is the data type. The first argument will be the data type, and the second argument is to read the data, right? So I'm going to close this. So I've closed. But this one is not having any limiting point, right? You can, with this statement, you can read any number of values. But my point of concentration is I just want to read n elements. To restrict my reading process, I'm going to use a slicing operator, right? So 0 to n minus 1 values, index values, it is going to read, right? So I have used a slicing operator. Very good. Now, a function called selection sort. I'm going to give a relevant name. Okay, guys. So it is always advised to give a very useful or a known function, the known functions or the name of the function should be in such a way that it depicts what the function does, what is the activity of that function. So selection sort is the name which I have given to the function, right? So this is nothing but a function call, right? So once I complete this selection sort, that is, once I sort the elements, I just want to see the output. I just want to see how they got sorted. What is the final result? So for the final result, the sorted list, right? This is the small statement I'm going to use, sorted list. So I just forgot to close it, right? The sorted list. So in the driver code, I have read the size of the list which I'm going to sort. Then I have read the elements in that list. I've called a function to which I have passed my list as a parameter. Once the control comes back to the driver code, once it executes that function, finally I'm going to print the sorted list. So these are the 4 bits and pieces of the code which I have written. My basic job, the basic current job, is to write the function for the same, to implement selection sort. Let's do it. Def. The only parameter that I'm going to pass to it is the list which I have read. Guys, a small typo error, which is, guys, please be careful. The name of the function must be as it is. Remember, Python is case sensitive. Even yahan se udhar, as lower into upper goes, it will just say unidentified. Or the if I left that capital O in sort, which is my typo error, it will just say at the function call place in the driver, it will say undefined function, right? So be careful, please. Right. So once I have declared it, that is the function declaration, let me write the body of the same. So for I in range of length of for all the elements. For all the elements, I'm going to run my show, right? So the outer loop is going to run for 0 to n minus 1, right? Then coming to my inner loop. Before going to go to the inner loop, what we have learned, to wherever I is going to point, even m is going to point to that element, right? And we have learned that by the end of each iteration, m will be pointing to the minimum element in that sublist, right? So I'll name it relevantly. Rather than m, I'll give a beautiful name to that. That is min index, right? So it will be holding the value of I, right? So let me start my jth loop, which will start from, what did I tell you? It will be just ahead of I. So if I starts with 0, j will start with 1. 0 plus 1, 1, right? So whatever the value of I may be, j will start with the value 1 more than I. The next very consecutive index value j will be pointing to. So till where it is supposed to go, it is supposed to go till the end of the list. That is the highest index value. That is the limiter, right? So I do not remember the length of my array. So I'm calling that function itself. Please, you take care of that function of array. So length of array is going to take care of that. It is going to set the stopping point, right? So let's go for the comparison. What we have compared? We have checked whether the element pointed by the minimum index, that is m, is greater than j or not. Let's place it out there. If the element pointed by minimum index is greater than the element pointed by j, if this condition gets satisfied, then minimum index position will change to jth position, right? If that condition fails, minimum index position is not going to change. It will be as it is where it was, right? So once it's so, the inner loop is going to run to find the least element with its corresponding index value in the given sublist. Once this is gets n, that is once j gets out of its limits, then we have to swap the elements pointed by I and m. Let's do it. A of I, A of, so our list name is ARR of I, ARR of min index is equal to min index, ARR of I. So this will end my job in every iteration. This will be the last step for every iteration, right? It will be the last step of every iteration to bring the minimum element to the lowest index value in that current iteration. So this outer loop is going to keep track of iterations. Okay, and this inner loop is going to take care of comparisons. Okay, So this is the basic condition I'm going to check for. So if you are going for ascending order condition, for ascending order, right? So let me save this one. First of all, guys, always use a relevant name so that whenever you go back to your scripts folder and try to check where you are, whether which function you want to retrieve, it must be a user friendly one, right? Looking at the name of the program itself, script itself, you must be able to retrieve it, open it, right? Similarly, with the function names also, please give relevant names, guys. Any novice who opens the script must be able to understand it, right? So let's go through the function which we have written. So I have read the maximum number of elements. Then I have written a map function to read n number of elements and place it them in my list. Then I've called the function, and my control will go to the function definition, where I'm going to I have written the code. I think this code is sufficient, right? So then come back to the driver code and print. Let me save this once again and let me run this one. Okay, it is asking for the number of elements, say 6. So with the elements be 4, 3, 5, 6, 1. Guess I have given these random elements and the list is 1, 2, 3, 4, 5, 6. Yes, the list is sorted, guys. Right? So this is a selection sort. Let me take you to the script of the same. Just guys have a look at this one. This is a selection sort technique whose complexity is n by n, right? And it is an in-place stable one. It's work very good if you have handful of elements, not more, because it is a straightforward sorting technique, and it is mostly used in the cases as an embedded sorting technique for a small list. If you are having a huge list and you have adopted a technique which can easily handle such a huge list, at an intermediate states wherever you are having handful of elements to sort, you can easily use selection sort to sort those elements, right? So with this note, I would like to conclude that we have seen what selection sort is, what is the basic algorithm of selection sort, a small example on the same, and a Python code for this. Please do follow my videos, guys. I've already shared quick sort, merge sort, bubble sort with you, and soon I'll be posting insertion sort. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.